I think I had left you with trying some of the questions here to do with the change of base rule, if I'm not mistaken. Remember that the change of base rule is just a way of changing an expression in whatever base it happens to be into some other base, usually so that you can evaluate it on your calculator. So you'd be changing it to base 10 then, but you could change it to any base you want. Right? If you have log base something, a of b, you can change it to some other base, and it's just log b over log a in whatever base you happen to be talking about. Right? And so some of the questions down here you were hopefully trying for yourself. You have from the straightforward something like that, right? Evaluating it. If you don't have a base 5 key on your calculator, you can still evaluate that just using this rule, right? This should be equal to log of 160 over log of 5, and then it's just a question of putting it in your calculator correctly. Even if it's some other base like that, you could write that as, if you have log of one thing over log of another thing and it's the same base, you could just write that as, kind of using it in reverse. What is that the same as? Log base, not minus, no, because it's a logarithm of each. It's using the change of base rule in reverse, right? If you go back up here for a second. If you have log of one thing divided by log of another thing, you can write it as that, right? If you have log 7 over log 4, you can write it as log base 4 of 7. All right, so you can write this one as log base 2 of 7. And then, that's wonderful. Math 12 is the only place you'd want to do that, right? Writing it as a single logarithm, even though you don't have a key to evaluate that. Some of the other ones here, write this in base 9 logarithms. If you have this expression, you want to write it in base 9 logarithms. Again, it's log of y over log of 3, but if you want it in base 9, you do this, right? Now, maybe the bottom part is the part that's hard to evaluate here. How could you evaluate that bottom part? Because if they're both numbers, you can actually evaluate it, right? If it's y, like it's y on top, it's got a variable, you can't evaluate it. But if you're evaluating the log base 9 of something, you need to know what power of 9 that is. How could you write this as a power of 9? Yeah, that's the square root of 9, so you could write it as 9 to the 1/2. So this expression on the bottom you could make equal to log base 9 of 9 to the 1/2. Right, if you're wanting to do this like that. Log base 9 of 9 to the 1/2. So then what's on the bottom? How do you evaluate that thing that's on the bottom? It's just 1/2, right? Log base 9 of 9 to the power of something, that cancels out, right? You just have 1/2 on the bottom. Or in other words, what's that going to be equal to? Dividing by 1/2 is the same as, you learned this in grade 8 actually, you don't write it like this, but you write it like this. Dividing by 1/2 is the same as multiplying by 2, right? 2 over 1, 2. So dividing by 1/2 is the same as multiplying by 2. Log base 2 log base 9 of y. Probably as simple as you can write it using base 9 logs. That's not the only way to do it. I mean, you could do it other ways if that works for you. But you should still get to this regardless of what you do. These ones with fractions, I think some of us get caught up in the fractions, not in the logarithm laws involved. 1 over log base y of 5. If you're working with, and you're trying to write this as a fraction now using the change of base rule, I would say this is equal to 1 over, I would use a big huge line. That bottom thing, log base y of 5 is log 5 over log y. You might as well, if we're doing base 25 logs, then we should put 25 here, right? Base 25 logs. I don't want us to get hung up or caught up in the complex fractions within other fractions, right? You have a big fraction and little fractions within that. You have done that again like this, right? In grade 8, you didn't write it like that. You wrote, if you have 6 divided by 1/2, you could have written that as 6 divided by 1/2 and had fractions within fractions. You have to just think back to what it meant here, and it's the same thing here. If I have 1 divided by this fraction, what is that the same as? 1 divided by that's the same as 1 multiplied by reciprocal of that, right? However you think of doing it, if you think of 1 divided by 2/3 is actually what? 1 divided by 2/3 is a reciprocal of 2/3, 3/2, right? So if you have this on the bottom, you could write it as, flip it over here, log base 25 of y over log base 25 of 5. Of course, you don't have to write the 1 times in front if you don't want. And then what could you make that bottom expression into? It's kind of the same as the previous one, isn't it? How could you change that around? If you want to do the log base 25 of something, you got to write it as a power of 25. How can you write this as a power of 25? It is, what is it? 25 to the 1/2, right? 5 is the square root of 25, right? So log base 25 of square root of 25, or in other words, 25 to the 1/2. That's what the bottom part is. I should write out the whole thing, of course, not just the bottom part. Move this a bit. Okay, so that whole expression, log base 25 of y over log base 25 of 25 to the 1/2. So then, of course, you have same as the previous one. Log base 25 of y over 1/2, or in other words, 2 log base 25 of y. This last one involves similar things. You have 2 fractions you're adding. I'm not going to go through the steps right now, but you need to think about if you're trying to add 2 fractions together, you have to go back to what you know about adding fractions. If these were the same, what could you do right away with those? If this was an 8 here, if they were identical, if the denominators were identical, what could you do right away with that? You could just add them. If they have the same denominators, you could say 2 of these and 1 of these is 3 of those, right? They don't have the same denominators, so you need to change them so that they do. You notice how we had 1 over something here, and we turned it into a fraction. Well, first of all, a fraction that had a number on the bottom. We turned it into then actually something that wasn't even a fraction at all. So you could certainly change some of these around for yourself here. If you try writing what each of those is equal to, right, the similar way here. I don't want to tell you how to do it though, so my hint is that change them so that you create some expressions that have common denominator and you can add them together. Like certainly you could write this bottom one here, log m over log 4, and you could do it in base 2 because 4 and 8 are both connected to 2. You could do this one the same way, right? I said I wasn't going to do it for you. Log base 2 of m, log base 2 of 8. Again, if you're wondering why I'm choosing to use base 2, it's because the numbers that I want here are nice numbers to use base 2 with, and then I can change them so they're not logarithms anymore. It's probably best, again, if you ever have complex fractions like this, deal with simplifying them first. 2 divided by that fraction is the same as 2 times the reciprocal of that. You'll eventually get some things that have a common denominator, and you can work from there, okay? Are we okay with that? Try seeing if you can come to a expression there. All right, so if you change this around here and make it with this on top, okay, write the fraction this way. Okay, you end up with that on the bottom. And you end up with this, 1 times log base 2 of 8 over log base 2 of m. You don't have to use base 2 logarithms. You can get it to be a single logarithm even if you just use base 10. You won't be able to evaluate everything, but on the top there, you could evaluate what each of these are, right? You could evaluate that as, what's log base 2 of 4? Log base 2 of 4, 4 is like 2 squared, so it's 2, right? If you have 2 times 2 on the top of this fraction, oops, too quick on the draw. Log base 2 of m on the bottom. And the other one, what's this equal to? Log base 2 of 8, 3, and then on the bottom here, log base 2 of m. And if you add all that stuff together, you got 4 plus 3, because now it's the same denominator. So you're going to have 4 plus 3 over each of those things. So you're going to have 7 over log base 2 of m. If you want, you can make it so it's not, I mean, this is already writing it as a single logarithm. If you want, you can do what we did up in the previous one, is simplify this so that it's not a fraction like that. I mean, you can, it's like anything, you can keep kind of working with things and changing it around until it's what you want it to be. You could make that one 7 over log m over log 4 if you wanted it, or log 2 if you wanted it to be in base 10 logs. You could make that into 7 times log 2, whoops, keep putting a base there, log 2 over log m. Now how could you write that? 7 times, if you have this fraction here, what does the change of base rule say you could do there? Log base what of what? M of 2. The reason I do that is not necessarily there's anything wrong with this, but if you compare this, dividing by log base 2 of m is like multiplying by log base m of 2. Does that make sense? This, if you're dividing by that, or in other words, if you have 7 times 1 over that, log base 2 of m, 1 over log base 2 of m is the same as log base m of 2. Just, it might help to notice that connection there, that it's like reciprocals, right? I mean, it's sort of like saying 1 divided by 2/3 is multiplying by 3/2. Similar thing here, right? Dividing by log base 2 of m is like multiplying by log base m of 2. It isn't that you have to change it to this. There's lots of right answers there. I mean, this, and it says write it with a single logarithm. That involves a single logarithm. The one above it involves a single logarithm. But just some things to note there. Any questions about that before we start talking about some graphing? Switch gears here a little bit.